In order to get started with this, what we're going to do is look ahead and think about what we're going to be using this password for. When a user signs into a site, typically that user will submit a password using a sign-in form. And we're going to need to compare that submitted password with the encrypted password in the user database. Now, we can't do a direct comparison because the submitted password won't be encrypted. So what we're going to end up doing is encrypting the submitted password and then comparing the encrypted values with the value stored in the database, this encrypted password value right here. In order to do this, it's useful to define a hasPassword Boolean method on user objects that will return true if the user has the given password. So let's write a test for that. Say inside password encryption, describe hasPassword, the question mark method. It should exist. We're going to say that this method should exist. So @user dot should respond to hasPassword. Notice that we can actually just put this has_password question mark as the symbol. The symbol can have a question mark in it, so this should fail because there is no such method. And now let's define one. And let's give it one argument. Let's say it's going to take in a submitted password. Now, this is really fine-grained test-driven development. Notice we haven't actually done anything with this hasPassword method, but we already have a test for it. And I think you'll find, as you get into test-driven development, that this sort of back and forth is a really nice way to work. So we've done this. Now, now what do we want this hasPassword method to do? Well, it should return true if the passwords match. And it should return false otherwise. So what does it mean for the passwords to match? Well, @user dot hasPassword of the attribute hash of password. So let's take a look at this thing at the top here. Here's the attribute hash, and so we're going to pull out the password, which in this case is just foobar. So we're going to say @user dot hasPassword. This is just the string foobar. This should be true. Because this is in fact the password for the user. So when we call @user dot hasPassword question mark and pass it the actual password of the user, it should be true, and if we pass something else, it should be false. So let's do this. Notice we can use b_true as a way to test b true. So let's be false. And let's just put in something that we know is invalid. Let's just put the word invalid. Okay, so we're red, which is good. So now, what should this hasPassword method do? Well, remember now, the user has an encrypted password. And what we want to do is compare the submitted password with that encrypted password. So the way to do that is just to say that encrypted password, this encrypted password attribute, is equal to, with the double equals comparison operator, the encrypted version of the submitted password. Notice that I didn't do the self dot here with the encrypted password because we don't need it. We could put it there. We could put self dot, but since this isn't an assignment, we don't need the self dot. And notice that we were green. Let me just run that again. So this is now working, even though we haven't actually done any encryption. And what's nice about this is now that we have a green test suite, we can actually go into this encrypt method and do some real encryption. And as long as the test suite stays green, then we can be confident that the encryption is actually doing what we want it to do. So in order to learn a little bit about encryption at this point, we're going to go back to the console. As you can see at the bottom of the screen, we've got this encrypt method, which currently does nothing. It just encrypts a string by returning the string, but that's not a real encryption. Let's take a look at a library that you can use in Ruby to do a real encryption. going to require the digest library. And let's take a look at how this works. I'm going to just do an explicit one here. Digest. This is kind of a strange notation. In fact, I find it hard to remember. So this is what's called a SHA, which is a particular kind of encryption. And we're going to use what's called a hex digest. Now, this is pretty advanced stuff, and the truth is that I just learned this by, Googling around and looking at other people's source code. So let's just see what happens if you run a SHA-2 hex digest on the string foobar. All right, so it returns this long, extremely difficult to guess thing. So let's see what happens if we define a secure hash method here in the console. So I'm going to do def secure hash. And it's going to take in a string, and it's going to return the digest of the string. Now suppose we have a password, which is just the word secret. Not a very good choice for a password, but there it is. And now let's make a local variable called encrypted password. And let's use our secure hash to encrypt it. Now suppose that the submitted password is secret. Now if we were to do a comparison with this, it returns true. Now, this encrypted password here is impossible to guess, but there's still a problem here, which is that if you were able to guess the hashing algorithm that we're using, which isn't too hard to guess, there aren't a whole lot of commonly used hashing algorithms, then you would be able to go through potential passwords and compare the encrypted versions of those passwords with this hash. So, for example, if we were to do secure hash of the word secede, and compare it to the encrypted password, we would get false. But if we were then to pick another couple values, say second, we're just going through some common words. Secret is our next thing that we're going to try as an attacker. And so now we've got a match. So if we were somehow able to get our hands on the database of these hashes, we could, in principle, figure out what the passwords were. Now, this isn't all that likely, but it's fairly simple to make this a lot more secure by adding what's called a salt. The idea of a salt is to make a string that is unique for each user. And so that way, we can foil this kind of attack, which is known as a rainbow attack. The salt we're going to use is a combination of the current time and the user's password. This way, the salt will actually be different even if two users have the same password, as long as they don't both create their users at exactly the same time. So let's take a look at how to do time in Ruby. So you can do time.now. Tells you the current time. But for time zone purposes, it's nice to use UTC. And so now if we, instead of making a secure hash of the password, we were to make a secure hash of time.now.utc combined with the password, then that could be used to encrypt the password in a secure fashion. So let's assign a salt, which is going to be a secure hash. And now we're going to interpolate in a string, time.now.utc. And it's conventional in this sort of context to just use a couple of dashes to separate things. And now we're going to put in the password. We actually don't need the password here. This just varies on a per user basis. This way, we have a salt that is different for two users who happen to create their salts at the same time, and it's different for two users with different passwords. And the only way these can match if two users with the exact same password were to create their salt at exactly the same time. So here's the salt. And now we're going to encrypt the password with that salt. So encrypted password is equal to secure hash. Notice we're reusing the secure hash function. So here's the salt, which is unique for each user, and then we're going to hash the password. And there we go. This is an encrypted password that is unique on a per user basis and is virtually impossible to guess. So let's take these ideas and implement them in code by adding a salt to the user model and then making an actual secure encrypt method here in the user model. So for example, to replicate this line here, where we compare the encrypted password to the secure hash of the submitted password, we're actually going to have to do it like this. It's going to be the submitted password, except it's going to have to be inside of this sort of interpolated string. So this is going to be submitted password. So that's true, as it should be. But what this means is that we need to keep track of this salt. So we're going to have to add an attribute to the user model and actually store this salt in a persistent way. So let's write a test for that. Say this is just in the password encryption block. It should have a salt. Say @user dot should respond to salt. And since we want to add an attribute, we need to actually add a migration. If we do Rails generate migration, and remember there's a special way to make a migration that is sort of pre-filled with stuff. We're going to say add salt to users, and then the salt will be a string. We've generated the migration, but we haven't changed the database. Let's migrate it, and then let's also db test prepare. Now it should work. Just doing space backspace there. Good, so now we have a salt. And at this point, we're ready to add some encryption machinery to the user model. And since our test suite is green, if we do anything bad, it should break and go red. So I'm going to start here by defining a secure hash method. In fact, it's going to be just the same as we had before in the console. It's going to take in a string, and it's just going to give me the digest of the SHA-2. There's also a SHA-1, but SHA-2 is slightly more secure. I'm going to encrypt the string using the secure hash and a salt. This will be the password, of course, but encrypt takes an argument here, as you can see. And now you may wonder why this salt isn't an argument to the encrypt method here. And the reason is because salt is an attribute of the user model. And just as in this section here, in the encrypt password method, we don't have to include password as an argument. We don't have to include it down here either. There's really an implicit self here, self.salt. So let's take a look at how to set the salt. We're going to do it in the encrypt password method. Remember, this is executing as a before save callback. But there's no need to make a new salt every time this object gets saved. Later on in this tutorial, we'll see how to let users update their information. But there's no reason to change the salt every time. So we're just going to store the salt once by assigning to it self.salt. Remember, the self dot is not optional when assigning to it. And we're going to defer the making of the salt to a separate method, just for simplicity. It's called makeSalt. And we're only going to run this if this is a new record. And there is a method for that, an active record, which is a Boolean called newRecord. The question mark. So this method here, this is really self.newRecord, but we can omit the self. So if newRecord, then we'll make a salt, otherwise this line won't execute, and then we'll encrypt the password. And now down here, I'm going to define a makeSalt method. And it's just going to be a secure hash. Again, this is based on our console session. I'm going to hash the time. .now.utc along with the user password. Let's save this and see if we're still green. Excellent. Now let's take a look at a console session, and let's create a user and see what happens. Remember, we're currently running in the sandbox here, so we're not actually changing the database. So let's reload bang, and now let's create a user. Let's assign it to a variable, just for completeness in case we want this variable. User.create bang. And so there we've created a new user, and you can see that, in fact, there is a salt here. So let's do user.salt and user.encrypted password. They're different, of course. These are not the same thing. The salt will not ever change, but the encrypted password will change if the user changes his password. And now let's see if we can do something, which is what we really want in life. Has password, question mark, and this is foobar. That's true. So what's happening here is this foobar string is being passed to the hasPassword method. It's being encrypted now according to this encrypt method, which is no longer trivial. It's actually using the secure hash with the salt and the string, in this case, the submitted password foobar, just down here. So that goes down to here. It hashes foobar, and then it does a comparison with the encrypted password in the database, and in fact they do match, so user.hasPassword of foobar is true. Now, having just created that user, let's pull it out of the database using the find by email method. So user equals user.find by email, and it was mhartle at example.net. And we can see that it worked successfully. This is how we're going to log users into our application, and then we'll just authenticate them using this. Of course, instead of hard coding the string, this will be the submitted password, this guy here. So at this point, there's only one more thing to do, which is to write a method that will be useful for actually authenticating a user. So I'm going to define a method that will let us write something like this: user.authenticate based on an email address and a submitted password. Of course, right now this doesn't work, but we'll fix that shortly. So let's think about the cases that we might run into in a real application where a user submits a password as part of a sign-in form, and we need to tell if that user is authenticated. Of course, they'll be submitting their email address as well. So let's write some tests for this. Let's describe the authenticate method. It should... Now, what should it do if the email address corresponds to an actual user in the database, but the password is wrong? In this case, we're going to return nil, indicating that no such user was found. So let's say it should return nil on email password mismatch. That is to say, the user with this email address doesn't have the submitted password. So in that case, we've got user.authenticate. Now let's use an email address that actually does exist. We're going to use the attribute of email. Remember, we're doing a create bang, so there is a user in the database with this email address. But we're going to use a password that's not right. So let's say wrong pass, indicating that it's the wrong password. So this should be nil. So remember, we saw be true and be false. You can also say be nil. Let's put in another test. Let's just say that it should exist. Probably should have done this before. User dot should respond to authenticate. This is actually nice because it lets us introduce another idea. So we've got two failing tests now. Because what we want to do here is define an authenticate method, but notice that authenticate is being called on the user class itself, not on a user object. So this is a class level method It's called a class method, in fact. And the way you define it is as follows. You do user.authenticate. And in this case, we're going to take in an email address and a password, submitted password. So in fact, we want to be green at this point. Oh, look at that. It is green. That's awesome. So what's happening here is that it's returning nothing. When you've got a blank body here, this method just returns nothing. And so what this be nil is actually true right now. So we're actually green. And before I move on, though, I want to show you a couple things about this. It's actually nice that we're green because people don't usually write user.authenticate in this context. What you would ordinarily do is something like this, self.authenticate. When you define a method with the self keyword, it's automatically a class method. Now, this is a little confusing potentially because I want to make sure you understand the difference here. This self here in self.salt or self.encrypted password is the user object that has been defined by, say, user.create or user.new or user.find by email address. In other words, this is a user object, an instance of the user class. This self refers to the class itself. This is the user class in this context. That's why I could replace user with self and still have the test pass. Just for what it's worth, and you will see this and it's kind of confusing, you can do this, class self do, and then inside this block you can define methods. And anything defined in this class self block is automatically an instance method. And I always get the syntax wrong. You can see it's not even passing. Yeah, so I actually don't want the do. It's just this. You can see how rarely I use it. It's a very confusing looking syntax, but it's quite common. And I definitely encourage you to be on the lookout for this. This just means anything inside here is automatically a class level method, which is called with this syntax user dot, where it's a capital user. All right, let's look at our other two cases. There's also the situation where the email address does not correspond to a user. So let's say it should return nil. For an email address with no user. And so now we just need to say user.authenticate, and we'll just put in an email address that doesn't have a user. Let's say bar@foo.com. And let's use a valid password just to make sure we're testing all the cases independently. So this is the actual password, but there is no such user. So this should be nil. And we want the authenticate method to return the actual user on a match. So in this case, we have user.authenticate. And now we're going to use the actual attributes of the user, in this case, email and password. Remember, this is just at the top of the file. The email is user@example.com, password foobar. And this should, what should this be? This should be the actual user. This should, now you can use the comparison operator, double equals @user. This is just what we want it to be. That it's okay if you wouldn't necessarily have guessed this, because we're getting into some pretty advanced password stuff here. But this is what we want the authenticate method to do, and you can see that this will be useful later on when we're letting users log into the site. Okay, so we finally got to red there. Notice that in the two cases where we needed nil, we actually already had nil, but now we actually have to do something. So let's take a look at this authenticate method. We've got an email address and a submitted password, so let's see if you can figure this out. I'm going to pull the user out of the database. You can see why this has to be a class method, by the way. We don't actually have a user yet, so we want to make it on the user class so that we can call user.authenticate. So find by email. Remember, we can do user.find by email with a capital user. This is this. But inside of a class method, we don't have to put it on there. We can just leave it alone. Just as before, we could omit the self.password here and the self.salt. You can also omit the self.findByEmail. So user equals find by email, and then the email address. So this will pull the user out of the database. And so now I'm going to be very explicit about what I'm returning. There are several ways to write this, and if you look at the Ruby on Rails tutorial book, in the exercises for Chapter 7, there are a whole bunch of alternate ways to do this. But this is a very clear, explicit way of doing it. We're going to return nil if, well, what happens if there is no such email address? So this is the case here, an email address with no user. Well, find by email in that case, we'll just return nil. So we're going to say return nil if user.nil. So if there was no such user with that with the given email address, this email address, then just return nil, and then return the user if the user has this password. So if we pull this user out of the database, and in fact the user has this admitted password, so now we're using our hasPassword method, then we're going to return the user. Otherwise, we're returning nil. So in the case that the email address corresponds to a user, but the password is wrong, then we'll just fall off the end of the method here, and it returns nil implicitly. That's why those two tests we're passing before, is because of that implicit return of a nil. So if I save this, we might very well be at green. There we go. Now the authenticate method does everything we want it to do, and we can reload the console here. So here's user.authenticate, mhardold.example.net, and foobar, and that in fact does return the user corresponding to this email address and this password, because this is the password of the user with this email address. Now in this case, the reason we wrote the hasPassword method and the authenticate method was at least half because we wanted to write some good tests for our functionality. And this is one of the nice things that comes out of test-driven development, is that the test code itself is a client of the application code. That is to say, it's actually using the application code to do something useful, in this case, writing a test suite. And oftentimes what you'll find is that as you're writing the tests, you'll just define methods naturally as part of the test writing process that will be really useful later on in the application.